Welcome to the Innovators, the podcast where we talk to the people building the future. In each episode, we sit down with technologists, founders, researchers, and engineers who are doing real, impactful work. They're applying technologies in ways that change how we live, work, and think. Whether it's breakthroughs in AI, climate tech, health systems, or digital infrastructure, this show is about the people turning ambitious ideas into working systems. No hype, just thoughtful conversations with the folks making it happen. Welcome back to the Innovators, a podcast where amazing people are doing amazing things. Today's amazing person is Charlie Welch, and his startup is called Proper Voltage. Welcome, Charlie.
Thanks for having me.
Yeah, so tell me a little bit about Proper Voltage. I saw some goodness about it, but it looks like you're transmitting power, essentially.
Kind of, almost like a universal adapter more so. So. As quick background, I used to work at Northrop in applied research and battery chemistry, and my job there was to basically get all of these interesting and exotic battery technologies into all of these military applications, from everything from airspace, underwater. I worked with the U.S. Special Operations teams, and what was crushing the best technology from being in the customer's hands was this integration paradox, in which we have a better technology if you're willing to completely redesign your product for us. And so that led to this kind of innovator's dilemma where it was, hey, battery company, can you redesign your battery for us? We'd love to use it. And they say, well, it's very expensive, very difficult. Can you redesign your product for us? And if so, we're happy to be in all your systems. And so instead of betting on one singular battery chemistry or technology, we wanted to build this universal battery operating system, this kind of connective tissue that lets any chemistry to connect to any application. So you're letting all these battery companies touch any market without having to touch any part of their assembly, manufacturing facility. And then you're giving products access to every battery technology. You're not just hoping that one technology is going to kind of solve the problem. And so we've kind of taken this approach of giving access to all these things is that kind of hidden piece that's kept all these better technologies from actually being in customers' hands.
So what does it mean to build a general? Is it like a generalized battery that should work in almost anything, or what's the situation?
Yeah, the way it works is we work with technologies like sodium ion, lithium titanate, niobium, all of these unique chemistries that kind of have their own superpowers, and then we build this hardware software layer where we can allow them to have voltage be a completely programmable interface, so that one battery system, whether it's sodium or this and that, can integrate into any product. So I can turn one battery system into a drone battery, a data center battery, a e-bike battery, anything in between, and the customer doesn't have to redesign their product to adopt it.
So it's because of the size of the battery. It's because of the shape of the battery. What's the special case there?
Yeah. So what's unique is the folks working on the chemistry breakthroughs. It's very hard to do that predicting every application, and so they kind of have to solve this unique chemistry problem, which is sodium ion has distinct advantages, but it does so at a 2.3 volt nominal instead of normal lithium ion, which is at a 3.7 volt nominal. So if I'm a product, to not change anything, I would have to add nearly twice as many sodium batteries to get the system to integrate, which means it's twice the size, twice the cost, all the kind of downstream flux, and it's twice the energy. It's just more than I would need. And so making voltage programmable through what we call a voltage command unit means that the sodium ion can integrate into any of those applications, match energy, performance, power, and we don't care about that lower nominal cell voltage, that the chemistry. And for the customer, they're like, I want to go with sodium because I'd like a safer technology that lasts longer, works better in cold, kind of thing.
And so what we're discussing like kind of like very, very specific types of technology. You mentioned military, for example. I mean, I can only imagine that each missile has a separate architecture, unless I'm wrong, and that there's like a generalized pattern for a lot of this stuff that you guys can just slot into.
There is, yeah. That's the goal, is that when there is generalized architectures, the switching cost is astronomical, which is like, if I've built all this legacy hardware in a missile or an aircraft, change it. If I have to touch anything on the aircraft to change it, it's just like a non-starter. And so if it's and that goes for things like the military 6T battery, which is like a backup power system for Humvees and tanks and this and that, or STUB, small tactical universal battery for soldiers. If you can get something that's plug and play and drop in, they're happy to adopt it. But if they have to redesign all their stuff to get a new technology, it's too difficult. Because if I'm, a big company building missiles or whatever it might be, if I have to go change suppliers and vendors and all my legacy hardware just for the battery, I'd be like, how, that's a big ask. So if it can just slot in and they don't have to change any of that because it will work with all their legacy and all their new systems, easy decision.
I think that the most interesting thing is that you are working in batteries. I don't think people don't think a lot about batteries. They just assume that, okay, if I want to have a battery, it'll be giant, it'll be heavy, it'll be kind of stupid too, because it'll be like 1,000 little AAAs that are all kind of like running series if you're kind of being lazy about it. What's the state of the art? What's the future for batteries? Will there ever be a case where I can, like, I don't know, power a laptop with a battery the size that's as thin as the screen?
Absolutely. Yeah, that's the entire goal, is that like there's all this great work happening, but it doesn't matter if it can't get adopted. Where everybody's focusing on these, like you said, a battery could be in a screen. Now there's batteries in wearables and clothes and stuff like that. And in my opinion, historically, betting on one technology is just not advantageous for the market, and it's not advantageous for the business. And so that's where this approach of building that one piece of kind of universal connective tissue is where you get to accelerate the adoption of everybody building those things. And that's both important for the DoD, but it's important for all these industries kind of building their business around what the battery can do.
What's the future of, I don't know, for vehicle batteries, right? Can we expect to see smaller, thinner batteries?
I think so. I think vehicles will hit a certain point where they'll just say, hey, 800 miles or 1,000 miles is good enough. For a car. Like, no one, after driving 1,000 miles, everyone's going to stop or have that period of time. But there are going to be big innovations around how long they last, like lifetime. So you'll have like an electric car that'll do 1 million or 2 million miles to actually offset, it sustainably. And so I think that will be just kind of a slow, steady progression. It's like Moore's law, just not as like steep of a curve.
When does that curve look like to you? It feels like the battery that's been in this phone for however many years has been the same one for most of the time the iPhone's been around, right? It's always been your little spicy pocket battery, lithium ion. I'm just wondering when there's going to be a step change in all this.
There won't be a big one, because the second there's more energy, they will run as much compute in the background as possible. Like the battery in your iPhone has gotten better, but your chips have gotten faster. Now we can like video stream or play video games on your iPhone. So like every extra watt hour they add into a phone, someone's going to take use of that. So the batteries have gotten like, I think it's roughly like 3% better roughly per year. And then Apple worked on some innovations where they made the battery like L-shaped so they could take more real estate and packaging and this and that. But the programmers that want your phone to do all the different things will take every watt hour they can get to run, higher processing and stuff. So.
And the same I would assume is true of, I don't know, a Humvee or a weapon or something like that too.
Totally. Yeah. That's the one challenge batteries have, is that when there is more, people have uses for it. Like they'd love to go faster. They'd love to, have it, have more power for a tank if they're using a directed energy system or whatever.
I guess
there's no shortage of what they'd use it for.
Yeah, I guess you already answered the question. Is there any pushback that when you come up to somebody and say, hey, we've got this great new technology, it should fit into your thing, but they're like, oh, this, whatever we have just works. You say there's a 3% change in the battery every year, which is big, but it's not perceived as big by the vast majority of enterprise engineers. Maybe software engineers, maybe they see that power is great, but the actual engineer probably doesn't want it to heat up, doesn't want it to get way more, etc.
Totally. Where we get those big step changes is when they fully switch chemistry. So like we worked on a project in the humanoid robotics space, and they were like, we want a Ferrari performance because we, under these really high dynamic movements, like jumping and running and doing all these things, the battery kind of can't keep up. And so they switched from the current chemistry they were using to a lithium titanate or lithium titanium oxide chemistry. And their charge time for the robot went from like 3 hours down to 6.5 minutes. And their peak power went up by 4 times in terms of like what it could do. And so that was where we were saying there is incremental improvements what you're using. There's also this big, beautiful world of like different technologies that will give you that like huge change that will help slot into your current system type of thing.
What's next for the company? What are you guys looking forward to?
Right now, it's our huge demand and is interest is in the, like, honestly, the backup power in telecom data center, basically the phasing out completely of lead acid and all of these previous technologies that are 50 to 100 years old. I think a bunch of technologies in the sodium ion and other space are going to really accelerate there, just because of, like, the US has majority of the raw materials for sodium ion, and so can have a completely domestic supply chain for it, which I think is really exciting. That has big implications both on the infrastructure side, but for some DoD applications. And so our three focuses right now are basically infrastructure, which is backup power for UPS data center, telecom, liquid natural gas, defense, so integration into things like the 6T, some drone applications, and some soldier wearables, and then I'll call them industrial. So, like, things that are robotics and industries like that, where battery performance is just, like, really critical for them to hit commercial viability.
Very cool. What's the website?
Propervoltage.com.
And if I need a special battery for, do you make batteries just for hobbyists as well? Do you have that kind of thing, or is it literally just all bespoke stuff?
Sometimes. So for hobbyists, oftentimes we say, what you're asking for is really close to this thing we already worked on. Is there any way we can send you this to go mess around with? Like the humanoid robotics battery, we're debating what world record we could set with it, just based off of, like, how insanely powerful it is.
Wow. So we're gonna have humanoid robots that can, like, last all day on a charge and still jump over a car or whatever.
Yeah, I don't know if it's possible because it relies on the robot as well, but we were throwing around ideas like how fast could it run a quarter mile, or could it, like, jump 10 feet high, or there's a couple of crazy ideas where, like, this thing is just bonkers in what it can do. So, like, what's something absolutely outrageous we could accomplish with it?
It's interesting that from your standpoint, that what the robot actually needs is more battery power. It's not a question of, I guess, the engineering of the legs. It's just like, can you get that little boost of power to get it to do that I don't know, crazy half-mile run or whatever.
So it's very specifically, it's actually stability. So, like, because we have this voltage, software-defined voltage command piece, a lot of times when robots are doing very high dynamic movements, voltage will swing all over the place. So we'll see huge spikes and huge droops and huge drops. With our system, you can regulate that, so the robot always sees one voltage from 100% to 0%. So not only does it get more power, but it performs the same at the beginning of life and end of life, which is, like, these subtle pieces of how these robots are going to use energy to make them, like, true smart batteries, so that they can learn about how they're being used and then deliver all of these new use cases.
And wouldn't that reduce the overall availability of energy? If you're doing that sort of, like, that flattening?
So interestingly enough, it doesn't, because normally they don't utilize the lower end of the curve fully, because when voltage gets too low, they can't handle the voltage changes at the lower state of charge. And so we actually access more of the energy that's there, because we can use all voltage from peak to 0%. Without any degradation. So there is a slight efficiency loss. It's just a couple percent in doing that when you're regulating it, but you get access to kind of more of the battery, and the robot gets more stable, kind of, like, access to that as well.
Yeah, very cool. I guess we learned all kinds of things about robot batteries that we didn't know before.
Yeah.
All right, Charlie, thank you for this. This has been really interesting.
Yeah, likewise. It's a fun topic.
All right. So this has been the Innovators. I'm John Biggs. We'll see you next episode. Perfect.